a vaccine for COVID-19, which has wreaked havoc across the world. Now, joining us to discuss this further is Professor Andrew Easton. He's a professor of virology at University of Warwick's School of Life Sciences in Inverness, Scotland, United Kingdom. Thank you very much, Professor Easton, for joining us on The Brief.
You're welcome.
Let me start by asking you, could you please help us understand the development process of a vaccine, and how long does it take usually for scientists to come up with a vaccine for viruses such as COVID-19?
Well, it's quite a complex question because each approach for a vaccine depends on the nature of the virus itself. So, for example, if you look around, we have actually only a relatively small number of vaccines for virus diseases, such as polio, measles, mumps, rubella, etc. The development process is generally quite long and can be very slow. It can take a number of years to develop a vaccine, or indeed, even after several years, no adequate vaccine may appear. And there are examples of both of those extremes. We don't have a human coronavirus vaccine on which to base our work at the moment. But there are viruses for coronaviruses. There are vaccines for coronaviruses in animals, which may give some guidance as to how the approaches should take. Now, at the moment, the approaches are really based on trying to make a vaccine that's directed against specific proteins within the virus particles. So that the idea is, if you inject these proteins or introduce the proteins by some method, not as part of the infectious virus, but take the proteins apart and inject them, then they will raise antibodies that will provide a degree of protection against infection if you then meet the virus. There is a trial going on at the moment, which has been remarkably fast, probably the fastest ever that's been recorded, since the description of the coronavirus to manufacture of a potential product, and it's now being used in humans to test for safety. The real issue with these sorts of approaches is that once you've even got a product, you have to show that it works in animals and it has a safety profile that is acceptable. And then you have to move on to test it in humans. And that can take quite a long time, often 1 to 2 years. But in a situation like this, we would expect it to be accelerated. There are special provision for taking materials forward very rapidly. But even given that, the most realistic prediction at the moment is it may be as long as a year before we have the first types of vaccine that show really good efficacy.
Okay, now, Professor, moving forward, when it comes to viruses, the coronaviruses, were scientists and experts able to develop a vaccine to treat the SARS virus? Because it's been more than 15 years, if I'm not mistaken. But do we have a vaccine for the SARS virus or not?
No, we do not. There was a lot of work that was carried out when SARS was around in 2002, 2003. A lot of money was invested in trying to develop a vaccine. But you'll recall that the incidence of SARS was relatively low. It was about 8,000 cases. It was constrained, and it was stopped in its tracks. The SARS has never reappeared since that time, and because of that, the pressure to try and generate a vaccine disappeared, and the work was effectively stopped. So, unfortunately, had that continued, we'd be in a much stronger position now to potentially develop more rapidly a vaccine for this virus, which has some relationship with SARS, of course.
Definitely. And Professor, now let me ask you, the fact that scientists were able to develop a vaccine for COVID-19 in such a short span of time, does that mean that the SARS virus was much more dangerous than COVID-19?